Okay, we continue with our discussion on the periodic table. We're going to discuss on part A the basic features of the periodic table. By now, I know I've discussed all these, but it doesn't hurt to emphasize. Now, a row in the periodic table is also called a period. A column in the periodic table is also called a group. Okay, now see how it's written 1, 2, 3, going from left to right up to 18. This is listing the columns, those are the rows. Okay, so like hydrogen and lithium and sodium, they are hydrogen, lithium, and sodium, then the same group, group 1. Oxygen, sulfur, selenium are in the same group. Fluorine, chlorine, bromine, same group. Helium, neon, argon, same group. We call a column, or column we call a group. And then lithium and beryllium, those ones are in the same row or period. Oxygen and fluorine in the same row or period. That is what's being explained here. The main group elements consists of the tall columns on the right and left of the periodic table. So we are saying that the main group elements will be are these tall ones, the blue ones. Those are the main group elements. And so we can just count by skipping 1, 2, third group, fourth group, fifth, sixth, seven, 8. And that's why they are called A. Those are main group elements with A. You ignore the transition mirror elements when you are considering main group elements. But overall, there will be 18 groups if you count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18 groups. But since you are skipping these 10 groups here, in main group elements, we just go up to main group 8. Okay? So, the transition mirror elements, they are the short ones that I told you we are skipping. They are the 10 short ones. They are numbered 1b to 1a. They are numbered 1b to 8b. So they are these ones right here. These ones, they are transition mirror elements as labeled. And the transition mirror elements are numbered 1b to 3b. They are 10 short columns. These ones that I put down here is like a valley. So 1b will be this group right here, 2b will be this group, this will be 3b. Now you come back here, 3b, 4b, 5b, 6b, 7b, 8b is from group 8, column 8 to column 10. That all those will be 8b. They are all included in 8b. Okay, that is a feature of the periodic table. And then you have what we call inner transition mirror elements that consist of some rare mirrors called lanthanides and actinides. There are no group numbers assigned because they are sliced off the periodic table, and they are right here. They are right here. I talked about this before. So these are lanthanides. Lanthanides would be on the period 6, sliced from period 6. So lanthanides belongs here. All these elements were taken out. They were sliced off the periodic table because of how common the chemical reactivity is. Actinides are sliced off period 7, and they include these elements right here. We call those inner transition mirror elements. Okay, but they belong to transition mirrors. Okay, so remember again, the long tall columns, those are the main group elements. And then these that you see here in brown, I don't know, teal color, those are the transition mirror elements. But within the transition mirror elements, you have elements that was sliced off. Those are the inner transition metal elements, these guys. Okay, and so I've discussed how the features of the periodic table. Other than that, you have metals and nonmetals in the periodic table. We talked about that. So when you are discussing the periodic table, we usually focus on both the groups and the periods. Now, I don't know how I'm going to sketch this, but my main focus is this. So this column and this column 1A and 2A, they are tall, so those are main group elements. So 1A, the group 1A, they are called alkaline metals, and group 2A, they are called alkaline earth metals. Alkaline metals will include lithium, sodium, potassium, as you see them here. Lithium, sodium, potassium, although hydrogen is sneaked in there, but we know hydrogen is a nonmetal itself, but anyway, he reacts by losing one electron, so he was put in main group 1. Potassium, rubidium, cesium, francium, those are main group 1. They're called alkali metals. Alkali earth metals include calcium, magnesium, but it's not limited to these. You also have beryllium. You have, I think that is strontium and barium. Okay, those are alkali earth metals. The common characteristics of group 1A and 2A main group elements is that they are soft, they are shiny, they have low melting points, they are very good conductors of heat and electric current, electricity. They react with water to form basic solution, and actually group 1A elements, they react violently with water, creating fires. But we know when group 1A and 2A are dissolved in water, for example, if you take sodium and put him in water, you're going to get sodium hydroxide and hydrogen gas. We'll talk about balancing equations later. I will not balance it yet, but that is the basic solution. Sodium hydroxide is one of the strongest bases. Now for alkali earth metals, if we take magnesium and put him in water, leave it there, it's going to give us magnesium hydroxide. We'll discuss later how to find all these equations and balance them. That also is a basic solution. Okay, so now there's a slice off of group 1A, which is coming from here. You see hydrogen is omitted because it's not a metal. It's just put there because it reacts by losing one electron, just similarly to lithium, sodium, potassium, rubidium, cesium, and francium. And then you have the group 2, main group 2 here, blown up here. That's main group 2, includes these guys. Okay, so in summary, again, we called these alkali earth metals, and these were just alkali metals. Okay, and then if we can skip to the other main group on the extreme right, talk about main group 7 and main group 8. So what you're looking at, okay, so we are skipping the transition metal elements. Then we go, so we are looking at the last two columns basically. We are looking at the last two columns. So pretend that this is 7A or 17 overall, and pretend that this is 8A or group 18 overall. So the group 7A on the very right hand side of the periodic table, I hope I did not say left, is group 7A and 8A. They are found on the very right side of the periodic table. This last group here, so 7A will be here, 8A will be there. So talking about those, 7A will include halogens. 7A includes halogens. They include halogens. These ones, when combined with metals, they give you salts. Example will be fluorine, chlorine, bromine, iodine. I think we have 80 under the iodine. Do we? Let's look at the periodic table. Yeah, we have 80 and we have TS. Those are called halogens. Okay, they are 7A, group 7A elements. They usually exist as two atoms joined together, so we say that they are not bi, we say that they are diatomic elements. They exist naturally as diatomic elements, meaning you'll never get fluorine in nature by himself. He will be a radical in that case, or an anion, which is very unstable. Fluorine will be diatomic, F2. Chlorine will be diatomic. Bromine will be diatomic. Iodine 2 will be diatomic. They're usually reactive by gaining electrons because they are nonmetals. Nonmetals react by gaining electrons. On the other hand, on the very last column of the periodic table, we have the noble gases. The other name of noble gases is inert gases. Why? They rarely combine with other elements. They rarely react. There is special circumstances where noble gases will react, but under natural conditions, they usually don't react. Examples of these will include helium, neon, argon, and then I think we have krypton. Let's see, you have krypton, xenon, radon. Those are main group A elements, or overall column number 18. They are very stable because they rarely react. That's why they rarely react, because they're very stable. When we talk about the electronic configuration, you will realize that all their orbitals are fully filled, and actually we would say that the octet rule is satisfied already for these elements. They don't have any room to gain electrons, and they don't need to lose the electrons like metals do. So metals will react by losing electrons, and metals will react by gaining. These ones will not do that. So this is a slice out again of main group elements. They are quite stable, and so we call them inert gases. They usually exist as gases, and the other word for them, name for them, is noble gases. They are found to the extreme right. And then main group 7 would be the second last column. We talked about the halogens. These ones, we say that they are mostly diatomic. They don't exist singly. These ones are usually monoatomic. They exist singly. Argon is just argon, is not paired up. Neon is neon, there's no twinning of it. Helium is just by himself, is one atom at a time. But for group 7A, we say that they are diatomic elements. These are diatomic elements. They are found in nature, bound to their twins.